The efficiency of an oblique system is somehow defined in the forward and backward oblique and what their size across the flight strip is. In every oblique camera that is currently on the market, we're using a 45-degree angle for the obliques, and obviously having a 45-degree angle leads to a longer distance for the oblique cone to look into the world. That distance is based around a factor of a square root of 2, so roughly 1.4 is that factor. This is what the oblique cones must be longer in focal length than what their nadir counterparts are. When you're doing your flight planning, let's say normally this is done with the nadir cone, and you plan for a 5 centimeter GSD, then obviously you want to have the more or less the same GSD in the oblique, which is somehow not really possible because there is a scale in the oblique image, so a transition from front to back in terms of GSD anyway. But at least in the center where we measure what the GSD of the oblique cone should, we want to have a balanced approach to that. Since the oblique cones are smaller than their nadir counterparts in terms of its footprint, by moving around, moving the nadir part too far apart, that would create some kind of small gap in the oblique overlaps. And this is not the case with our setup, because our nadir footprint size is matched to our obliques. So if we fly a 60% overlap, for example, again, we roughly end up with in a 20% plus range of overlap in the oblique still.
And we're still doing another very smart thing, I believe, where we can shift the sensor up a little bit, right?
For our left and right-looking oblique cones, we decided to use them in a portrait mode because that just makes more sense to get a better coverage, basically. And we also shift the sensor slightly towards the airplane, and that basically results in covering more ground with a more meaningful GSD, because you want to have like the better GSD, the better imagery.